Hey dudes, welcome to my channel, Salamat 2020, and please don't forget to subscribe and click the notification bell to notify you in my next math tutorial lesson. For today's presentations on statistics and probability about the two types of random variable, discrete and continuous random variable. In this lesson, we will differentiate or classify the types of random variables that are discrete and continuous. And we will answer the questions here. How do you describe a discrete and continuous? And how do you know if the random variable is discrete or continuous? Here's the real-life examples of random variable. The number of medical team workers, the rolling of dice, another one, the kid's height, and the weight of a person. These are the example of the variables, and we will classify the example according to the types of random variable. We have here the objectives. Classify random variable as discrete or continuous. And so let's define first the random variable. A random variable is a variable whose possible value are numerical outcomes of a random phenomenon. A random phenomenon is determined by the outcome of statistical experiment where all the possible outcomes are set. We have the two types of random variables here. These are the discrete random variable, and the other one is continuous random variable. And we will answer here the how do you describe these types of random variable. Then how do you know whether a random variable is discrete and continuous? So let's differentiate the discrete and continuous. A random variable is said to be a discrete if its set of possible outcomes is countable. And mostly a discrete random variable represent count data, and we can get or find the value by counting. And also it can take only have a specific values like 1, 2, 3, 4, 5, and so on, and you could count a whole number of them. Okay, for example, the number of cats in our home. We know this is a discrete random variable, since in this picture it's very easy to count a natural number like having a number of cats. So this is countable. The value of discrete comes from counting, and we could count the whole number of them. Okay, for example number 2, the number of medical team workers. So in this example, this is countable. The possible outcomes, a group of medical team is countable, and the value is obtained by counting. And we have also the specific values for this group. Number 3, the score shown on the top page of rolling a die. How many outcomes are there in rolling a die? So we know a die can show a number from 1 to 6 in rolling a single die. So we can say a discrete random variable since it takes on a specific value in every element. So when do we say a random variable is continuous? A continuous random variable if it takes on the values on continuous scale. And it is also represent the measured data, and the values is obtained by measuring. And also it can take any values in our interval, and always something in between, like for this example given, the inequality 1 less than or equal to x less than or equal to 2. So this continuous random variable, it takes on any values of x between two specific values of 1 and 2. So the values of x here, or the set of values of x, are 1 and 1.1 and 1.2 and 1.3. So there's always something in between. The concept of decimal matter with this type of random variable, that is continuous random variable. So we have here the example for a continuous random variable. So first, the height of a person. So with this picture, the kid's height can take on any value, like for example 128.9 centimeter. We can find another person's height somewhere in between, like for example 130.5 centimeter. So it takes on values on continuous scale, and the value can be obtained by measuring and represented by measured data, and it takes any values for the height. Then number 2, the weight. The weight of a person is a continuous random variable. The weight could be take any value in an interval, like for 120.1 kilogram, and the other might scale as to 82.3 kilogram. So again, it is a continuous random variable, and it takes the continuous scale, and the value is obtained by measuring, and we have also the numbers between the specific values. And another example is the temperature. Temperature has a continuous character. Thermometer can take a measurement anytime. So we have here, it measures 98.6 degrees Fahrenheit. The another way around is 87.5 degrees Fahrenheit. So it takes on a continuous scale, represent measured data, and it takes any values, and there's something in between of the specific values. So these are the example for the continuous random variable, since all the values can take any values, or there's something always in between of the specific values, and the values can be obtained by measuring. So we have here the exercise. Then you have to classify the following random variable as discrete or continuous. Okay, number 1, the number of female athletes. So since the female athletes, it refers for the number that is countable. So this is a discrete random variable. Then the speed of a car. So the speed of a car, let's say the speed of a car to get or to find the values could you obtain might be 45.5 miles per hour, 62.3 miles per hour. So it takes any value and obtained by measuring. So this is a continuous random variable. So we have here number 3, the amount of sugar in a cup of coffee. So again, this is it takes for the value by measuring. So this is continuous. Another one, the number of voters favoring a candidate. So to find the number of voters, so the value is obtained by counting. So this is discrete. And the last number 5, the time needed to finish the test. To finish the test, we need to get the time by measuring. The value obtained by measuring, and this is the continuous random variable. I have here a prepared activity for you to classify whether a random variable is a discrete or continuous. Just comment down below, dudes, for clarifications, questions on the presentations given. I just wanted to impart to you, dudes, make this channel as your home of learning. Thanks for watching, dudes, and God bless us all.